The second way to solve a system of equations is substitution, and I think personally that's the easiest way, assuming that it's set up for you to solve it that way. So the substitution is the best choice when one or both of your equations are solved for a single variable. So that's the key there. One of your equations has to be solved for a variable already. So x equals something or y equals something, so you can plug what that expression is into the other equation. So first thing you want to do if you're using substitution is determine what variables should be substituted for an expression. Once you decide which one you're substituting in, substitute that in first. Second step, simplify or solve for that new equation that should now only have one variable. So now that you've substituted in that expression for whatever variable was solved for, now you should have an equation that has just one variable in it. Solve for that variable. The last step, once you find the first variable, now plug it in to find the second variable. So there are some special cases. Again, this is stuff you guys talked about in Algebra 1, maybe even geometry as well. But there are some special cases. The first case, when solving, if you get a false statement such as 2 equals 5, that's not true. So if you get a false statement, then it's inconsistent and the equation or system of equation has no solution. If they're not intersecting, if they don't have a solution, then your lines are going to be parallel. The second special case is when you get a true statement, but your variable has disappeared. So if you get something like 2 equals 2, or 15 equals 15, or 0 equals 0. If you get something that equals itself, then we say that the system has infinite solutions, or the solution set is all real numbers. And that symbol there is just a symbol for all real numbers. So on a graph, if they have multiple solutions that are going to make both those equations true, it's actually going to be the same line. The lines or the equations would be on top of each other. So now let's actually go ahead and try some of those examples underneath. Let's actually try A and B. So for letter B, we have y, the two equations, y equals 3x minus 13, and 2x plus 2y equals negative 10. So again, if we're trying to use substitution to solve these, we're looking to see, is one of our equations already solved for a variable? And I'm looking at this, and I'm going to say, okay, well, it looks like this equation is solved for y. And it's telling me that y is equal to 3x minus 13. So I'm going to take 3x minus 13 and substitute it right in there for that value of y. So instead of 2x plus 2y equals negative 10, you're going to have 2x plus 2 in parentheses, that expression, 3x minus 13 equals negative 10. And now you have an equation with only one variable, x. So go ahead and solve it. So you have 2x, distribute that 2 inside there. So 6x minus 26 equals negative 10. Combine your x terms, 2x plus 6x. Add the 26. And divide by 8. And yet x is equal to 2. So now that we have x, we need to substitute that in to get your y. So again, it doesn't matter which equation you substituted into, but I'm going to substitute into the first one just to find y. So y equals 3. Instead of x, we're going to do 2 minus 13. So y equals 6 minus 13. y equals -7. So as my solution, I'm getting the ordered pair 2, -7. So now we just have to check. So let's see, -7 equals, I'm going to plug it into the first equation, 3 times 2 minus 13. 3 times 2 is 6, 6 minus 13 is -7. That works. And if we plug it into the second one, 2 times 2 plus 2 times -7, does that equal -10? Well, 2 times 2 is 4. 2 times -7 is -14. So -14 plus 4, +4, will give us -10 equaling -10. So that is our solution. On the test, you may not have to check it, but if you want to make sure that you got the correct answer, it would be wise to check it. So I'm going to do letter C with you guys, and then you guys should try example A on your own then. So for example C, we have x equals 3y minus 1 and 4x plus 6y equals 8. So we're looking for which equation is solved for a variable, and that's going to be the first one. We have x equals 3y minus 1, and we're going to substitute 3y minus 1 into the second equation for x. The first equation tells us that's what x is, so we can substitute that expression into the other equation. So instead of 4x plus 6y equals 8, we're going to have 4 times 3y minus 1 plus 6y equals 8. And then we'll just solve for y, because now you should only have a single variable in that whole equation, which is y. So we'll just go ahead and simplify this. So we get 12y minus 4 plus 6y equals 8. 12 and 6y is 18. Add the 4 over and get 18y equals 8 plus 4, which is 12. So it looks like this one is going to be a decimal or a fraction, which is fine. So 12/18, if we divide both of them by 4, we get y equal to 12 divided by 4 is 3. Nope, not 4. 6. 12 divided by 6 is 2. And 18 divided by 6 is 3. So y is 2/3. So now that we have our y variable, or our y value, we can substitute it into either equation to solve for x. So now we solve for x. So we need to plug it in. So I'm just going to plug it into the first equation. So we get x equals 3 times 2/3, which is y, minus 1. So 3 times 2/3, you can always make that into a fraction, remember? So 3 times 2 on the top over 1 times 3 on the bottom gives us 6/3, which is 2. So x equals 2 minus 1, which is 1. So our ordered pair here is going to be x, which is 1, and y, which is 2/3. And again, you guys can always plug that in to check, so we'll do that real quick. So if we check, so we'll have x equals 3y minus 1, so 1 equals 3 times 2/3 minus 1. So 1 equals 2 minus 1, which is good. 2 minus 1 is 1. 1 equals 1. And then in your second equation, 4 times x, which is 1, plus 6 times 2/3. Does that equal 8? So 4 times 1 is just 4. 6 times 2 on the top is 12 divided by 3 is 4. So 4 plus 4 does equal 8. So it is okay to get fractions or decimals, guys. Remember, I said I will usually just keep them in fractions instead of turning them into decimals. But if I don't specifically say, either one is fine.